All right, down to our last two here. So perfect squares intro and perfect squares. And then don't forget to take those quizzes and tests. You can take them as many times as you like. Um, so if you get them wrong and don't do well, do them again. I'm not gonna go through those. All right, factor as a product of two binomials. So basically, you're gonna factor this, and then you're gonna realize that the two factors are the same. So you're just gonna write it a little differently. But I'm playing that same game where I'm trying to multiply to 9, add to 6. That's 3 and 3, right? So x plus 3, sweet handwriting here, x plus 3. So 3 times 3 gives me 9, 3 plus 3 gives me 6, so this is correct. But what they want you to do is realize that those are the same term, x plus 3 times x plus 3, and write it as x plus 3 squared. So you're not doing anything different um, until the end when you just kind of simplify a little bit. So same deal here. What two numbers multiply to give you 4 and also add up to give you 4 is 2 and 2, so that's x plus 2 times x plus 2. And they're just going to say, hey, write that as x plus 2 squared. Wait, what? Oh, I just got to do length. So it's x plus 2. My bad. This is why you guys like HACON. Factor as a product two binomials. This one I would probably reverse. I think most people are much better at factoring in standard form, which is when the powers get smaller as you go. And then find two numbers that multiply to 81, add to 18. Well, that's 9. And then they want, that's perfect squares, so write it as a square. And move on. This will be x plus 5. Kind of shortcut. I mean, this is the fourth one, right? So I'm trying to kind of skip steps. But if you square root this number and take half of that number, you should get the same thing. And then that's what goes in both those spots. So there you go. All right, so now we're past the intro into regular perfect squares. Let's see what we get here. So all right, let's start. I would rewrite it first in the order that I'm used to. So 49x squared plus 70x plus 25. Well, if it's going to be a perfect square, what goes there and there have to be the same. And not only do they have to be the same, it has to be true that when you multiply them together, you get 49x squared. So it has to be the square root of those, essentially. So this is 7x. I know there's this like 70 and the 49, and this looks messy, but if you follow through the same process, it's going to work. And then go over here. I know that this times this has to give me the 25. It might be helpful for some people to put this in a box and go, okay, this is 49x squared. And then these two have to be the same, and that's where I'm going, okay, they must both be 7x. And this box has to be 25, and I know these two have to be the same, so they must be 5. And I never even like worried about the 70 one bit. But if you want to, now that you've got the 5, 7x times 5 is 35x. You got the same thing here, so we have 70x's. So it's just a way to check, but you don't really need to think about it. The 70 with the when you're doing the work. All right, first thing I always want to check is, can I take a number out and make my life easier? And that last one I couldn't, and this one I can. I can divide these all by 3. This is where factoring gets tough, because there's always like the little twist and turn. And the way to get best of that is just practice. So I take the 3 out first, and then I've got this trinomial that I can factor. X squared must have been x and x. And then what two numbers multiply to 25 and add up to 10 is plus 5 plus 5. We kind of know because it's the perfect squares section. These two numbers should probably be the same. And then don't forget about that 3 that you took out at the very beginning. Let's do one more. I don't think these are the easiest for you guys, so we'll do a few. So put it in standard form first, so the powers go down. The perfect squares things really help. I mean, the fact that we're in the perfect squares section really helps, because now I know something times itself has to give me to 9x squared. Well, that's 3x. And something times itself has to give me to 4. And that's 2. Okay, this is even tougher than I thought. So now I'm going to check it, right? So I'm going to go 3x times 2 is 6x, 3x times 2 is 6x. Well, if I add those up, this would give me 12x, and I'm supposed to have negative 12x. So what I'm going to do is go, oh, if I make those both negative, now negative 3x times negative 3x is still positive 9x squared, but this gives me negative 6x, and this gives me negative 6x, so it's negative 12x now. That was a tough one. That's not a trick that most people are used to looking for, but hopefully this helps. That's why we're doing these, right? All right, so I'm going to stop there. The video's